Bismillahirrahmanirrahim. Force, inertia, and momentum. Newton's law of motion are of fundamental importance in understanding the causes of motion of a body. Before we discuss these laws, it is appropriate to understand various terms such as force, inertia, and momentum. Force. We can open a door either by pushing or pulling it, as shown in figure 3.4. A man pushing a cart. The push may be move the cart or change the direction of its motion or may stop the moving cart. In figure 3.2, a batsman is changing the direction of a moving ball by pushing it with his bat. A force may not always cause a body to move. Look at the picture as shown in fig 3.3. A boy is pushing the ball and is thus trying to move it. Could he move the ball? A goalkeeper needs the force to stop the ball coming to him, as shown in figure 3.4. Thus we understand that a force moves or tends to move, stop or tends to stop the motion of a body. The force can also change the direction of motion of body. What happens when you press a balloon? That's one question. You can cut an apple with a knife by pushing its sharp edge into the apple. Thus, a force can also change the shape or size of a body on which it acts. Inertia. Galileo observed that it is easy to move or to stop light objects than heavier ones. Heavier objects are difficult to move, or if moving, then difficult to stop. Newton concluded that everybody resists to the change in its state of rest or of motion in a straight line. He called this property of matter as inertia. He related the inertia of the body with its mass. Greater is the mass of the body, greater is the inertia. Inertia of the body is its property due to which it resists any change in its state of rest or motion. Let us perform an experiment to understand inertia. Experiment 3.1. Take a glass and cover it with a piece of cardboard. Place a coin on the cardboard as shown in figure 3.5. Now flick the card horizontally with a jerk of your finger. Does the coin move with cardboard? The coin does not move with cardboard due to inertia. Where does the coins go as the cardboard files away? Consider another example of inertia. Cut the strip of the paper, place it on the table, stack a few coins at its one end as shown in figure 3.6. Put out the paper strip under the coins with a jerk. Do you succeed in pulling out the paper strip under the stacked coins without letting them to fall. Okay. Momentum. A bullet has a very small inertia due to its small mass. But why does its impact is so strong when it is fired from the gun? On the other hand, the impact of the loaded truck on the body coming its way is very large. Even if the truck is moving slowly, to explain such situation, we define a new physical quantity called momentum. Momentum of the body is the quantity of the motion it possesses due to its mass and velocity. The momentum p of the body is given by the product of its mass m velocity mass m and velocity v.